Hey guys, thanks for joining me today on Thursday for your dividing decimals lesson. Now hang out with me for a little while and we'll do some practice on dividing some decimals by whole numbers. See you in a minute. Okay, my taste, we're going to talk about dividing decimals by whole numbers. So I want you to use these as your reference points again, right? Our base 10 blocks. Here's our wholes. Here's our tenths, because it takes 10 of these to make one whole, so this is a 1/10, and this is a 100th because it takes 100 of these to make our whole. So keep these references in mind as we talk about dividing decimals by whole numbers. Okay guys, so let's start talking about our dividing decimals by whole numbers with this word problem. Let's think about this for a second. Mrs. Jones has $2.46 to share with 3 of her children. How much money does each child get? Okay, so we have $2.46, and here's my 246, $1, $2, 4 dimes for 40, and 6 pennies for 6 cents. She has to share those with her 3 children. So here's my 3 boxes that we're going to split this money into to get to the 3 kids. Now here's why it's a decimal by a whole number. We have a decimal amount that we're going to split up or divide amongst 3 children, which they're whole children. I have no parts of children. So this is a whole number, and here's our decimal. This is 2 wholes, there's our green dollars, and then this 46 cents is part of a whole dollar. So there's 4/10ths of a dollar, which are the dimes. There's 10 dimes make up a dollar, and then there's 6/100ths of a dollar, and pennies are hundredths of a dollar because they are worth less. There's 100 of them in $1. So each one of these is a different place. So let's start splitting this up. So each child cannot possibly get a full dollar since I only have 2 and there's 3 kids. So we're going to take these dollars and we're going to split them up. So we're going to take this one and we're going to get rid of it and trade it in for 10 dimes because each one of those is a 10th and there are 9. So we're going to take rid of that dollar and we switch it out for 10 dimes. Still the same value. There's 100 cents here and there's 100 here. So there's my $2. Now I have 10, 20, 24 dimes that I'm going to split up amongst these 3 kids. So if I have 24 dimes to split amongst 3 kids, how many does each kid get? Right, each kid's going to get 8 of these dimes. So there's 3, 4, 5, 6, 7. And you'll notice that this is my tenths that I'm splitting up, right? Because those are dimes. Dimes are tenths. So I couldn't split up the dollars, so I had to scoot over to the tenths to split them up and trade out those 2 full dollars into dimes, so I was able to split them. All right, so there's my 8 dimes for that child. And then these last 8 dimes, I'm going to scoot on over here. Oop, in that box. Get in that box. Doesn't want to go down there. There we go. We'll scoot it on over here so that this child will also get 8 dimes. So as of this point, how much money does each kid have? Each kid gets 80 cents, 8 dimes. Okay, so we split up our tenths first. Now we're left with these 6 pennies. How many out of each of those 6 pennies will each child get? Well, this one's nice and divisible, right? Because 6 can be divided by 3, so each child's going to get 2 of those pennies. So as of this moment, each child has 8 dimes and 2 pennies, which is 82 cents. So if I had $2.46 shared amongst 3 kids, each child's going to get 82 cents. Okay? All right, so let's take a peek and see what this looks like in another way. Oh, hold on one second. I'm going to remove that, and then let's let it play. Let's look and see what it looks like as an algorithm, okay? So what we just did with our model, and we took that decimal, is we took that $2.46 and changed it into those 3 people. Now when you're using the algorithm in the formula, take a look at my numbers right here, $2.46 divided by 3. The number we're splitting up goes on the inside. The first thing I'm going to do is raise up that decimal straight up to the top. I'm going to keep the same place values. I don't want to move it to the left or the right. It's going to stay in the same place. It goes to the top of the bar. Then I'm going to start dividing. How many times can $2 be split by 3 kids? It can't. So I'm going to put a 0 there because I couldn't split those $2 amongst 3 kids. If you remember, I changed them each for 10 dimes, which were tenths, so I switched them out for 20 tenths. So we're going to add those 20 tenths with the 4 tenths that are there to have 24. So now I'm going to divide how many 3's can go into 24. 8. Now we're going to multiply. That 8 times 3 is 24. We subtract. 24 take away 24 is 0. 0 is smaller than 3, so I know I did that appropriately. Then we're going to bring down that 6 to create a new number. So now I'm going to divide all over again. I have now just the 6 pennies left. I used up all of the tenths, the 24 tenths, which were the dimes, split them into 8 each. So each child gets 8 tenths or 80 cents. And then we're going to divide the pennies up. So how many 3's go into 6? 2. We multiply 2 times 3 is 6. We subtract, and that equals 0. There's nothing left over. Every child's allowed to get 82 cents. Okay? All right, now let's transfer over here and look at what this looks like as I'm doing models, and we're going to switch to the algorithm. All right, decimals commonly come in money, so in the last example, I split money amongst my 3 kids. But let's say instead I have these candy bars, and the candy bars are packaged like the Hershey bars are broken into parts. They are broken into 10 parts, and I have 1 5/10 of a candy bar. So here's my 1 5/10, my 1 whole candy bar, and then my 5/10, which is split right there. Okay, this candy bar I already ate. So we're going to split this 1 1/2 candy bars, or 1 5/10 amongst my 3 children. So just like with our money, we couldn't split that 1 whole by 3 kids, so we had to transfer that 1 into tenths. We're going to take this decimal and raise it straight up and not change its place value. And then I'm going to think how many 1s can go, or 3 can go into 1. None of them. Get into the habit of putting that 0 there so that you don't lose that place value, that 1's place value with the decimal. Okay, so 0 times 3 is 0. We subtract. 1 minus 0 is 1. 1 is smaller than 3, so I know I did a good job. Now I'm going to take these 5/10 that are left, and I'm going to bring them down to create a new number. Now I have 15 tenths. I can split these 15 tenths now into 1, 2, 3 equal pieces. So how many 3's go into 15? The number that I dropped, I'm going to place my number right on top of it. 3 goes into 15 5 times. 5 times 3 is 15. We subtract, and I get 0. No candy left over. So each one of those 3 children is going to get 5/10 of a candy bar. Okay? It is just like dividing with whole numbers with the algorithm ways. Dad, mother, sister, cousin, brother. If you remember, that was the trick that I gave you to make sure you remember all the steps. Unfortunately, the partial algorithms is not going to work, or the partial quotients, I'm sorry. And the big 7 that some of you use, we're going to have to all transition to the algorithm. Okay? All right, let's look at some other examples. All right, let's start with some single-digit division. 7 35/100 divided by 3. So we're going to split this by 3. Step 1, raise that decimal straight up. We're not going to lose any place values. How many 3's? Here's our family. Dad, mother, sister, cousin, brother. These are our steps. Dad first, divide. How many 3's go into 7? 1 step at a time. 2, because I can go 3, 6, 9. 9 too high, so I have to go back down. Mom multiplies. 2 times 3 is 6. Subtract for sister. 7 minus 6 is 1. The cousin compares. Is 1 smaller than 3? It is, so I know I did that correctly. So I'm going to scoot on over. We're not dropping this decimal down because it's just a placeholder, so we moved it up. So we don't need to drop that down. We're going to drop down the 3. How many 3's go into 13 now? 3 times 4 is 12. 3 times 5 is 15, too high. So we're going to stick with 4. The 4 goes directly over the number that I dropped, so I keep my place value. 4 times 3 is 12. 13 minus 12 is 1. 1 is smaller than 3, so I'm good to go. Scoot over to the 5. Bring down the 5. How many 3's go into 15? Well, that's easy. That's 5. 5 times 3 is 15. Skip this over. Is 15. I subtract and get 0. No leftovers, no remainders. 2 45/100 is 7 35/100 divided by 3. To check it, I take my quotient and I can multiply it by my divisor. And remember to place the decimal. How many spots are behind the decimal? 1, 2. 2 spots behind the decimal in the answer. If these two are correct, the same, I know I'm right. All right, let's scoot on over. Let's do a money problem. $920.64 divided by 4. The dollar sign and the decimal can raise straight up. They're just placeholders and symbols. Let's step one step at a time. How many 4s go into 9? 2. 2 times 4 is 8. I subtract to get 1. 1 is smaller than 4, so I move on over. 2. Bring down the 2. New number. How many 4s go into 12? 3. 3 times 4 is 12. Subtract to get 0. 0 smaller than 4. Move on over. Another 0. Bring down that 0. Even if it's a 0, you need to bring it down and go through all the steps. How many 4s go into 0? 0. Just think, if I would have skipped that step, instead of $230 right there, I'd have $23. So that 0 is very important. 0 times 4 is 0. I subtract and I get 0. Don't worry about the decimal because we move that up. Move over to the 6. Bring down the 6. How many 4s go into 6? 1. 1 times 4 is 4. Subtract to get 2. 2 smaller than 4. Move on over. Drop that 4. How many 4s go into 24? 6. 6 times 4 is 24. I subtract. I get nothing left over. I am done. I take my answer, $230.16, multiply it by my divisor. One, 2 spots behind the decimal. 1, 2 spots behind the decimal. 920.64, 920.64. I know I'm correct. All right, let's move on to some double-digit questions, and we'll see how we do with these. Same exact strategy. Dad, mother, sister, cousin, brother. Divide, multiply, subtract, compare, bring down. We're just going to use 2 digits. Now, when I get to these 2-digit numbers, I like to list my multiples. 13, 26, 39, 52, 65. I like to do some multiples. It'll help me not have to worry about them a little bit later. All right, let's start one at a time. There's my decimal. We're going to move it straight up to hold that place value. Start with the 6. Can 13 go into 6? No, it cannot. So we'll move over, bring down the 8. Can 13 go into 68? Yes, it sure can. 1, 2, 3, 4, 5 times gets me to 65. 5 times 13 is 65. Remainder of 3. Move on over. Don't worry about that decimal. 39. How many 13s go into 39? 1, 2, 3. 3 is exactly 39. So I put the digit right over the number I dropped. 3 times 13 is 39. No leftovers. So I'm going to take my answer, 5 3/10, multiply it by my divisor, placeholder, one spot behind the decimal, no spots behind the decimal here, so 1 spot behind the decimal in my answer. This and this are the same. I know I'm right. All right, let's try one more. And this one I have a star by because I'm going to show you something odd is going to happen with this problem. Let's see if we can figure out what. Don't let this 35 intimidate you. Just come on over here and do 35. That's 35 times 1. Then if I do 35 times 2 is 70. 35 times 3 is 105. Then 140. And you can set up some numbers over here to help you out along the way. All right, decimal. Straight up to hold the place value. Now it's gone. How many 35s go into 4? It doesn't. So 0 times 35 is 0. We subtract and get 4. Drop that next digit down. 41. Well, 2 35s would be way too high, so it has to be only 1. 1 times 35 is 35. I subtract and get 6. 6 is smaller than 35. Scoot on over. I have a 2. Well, over here where I was counting 35s, the second 35 is 70. It's too high. So again, it's going to be just 1. 1 times 35 is 35. 12 minus 5 is 7. 5 minus 3 is 2. Even though this is a high number, it's still smaller than 35, so I know I did it correctly. Now we got to drop this 3 down. Wow, 273 divided by 35. So I've got some work to do here. If I had 140, I got to keep counting by 35. That's 4 35s. And if I doubled that, it would be almost this, just not high enough. So if I doubled 4, it would be 8. So I'm going to test 7. I'm going to do 35 times 7 and test that one out. Ooh, 245. Let me just double check that I did that right and the 8 is too high. Yeah, 280, a little too high. So we have to stick with this one, 35 times 7. So 7 goes above the 3 that I dropped. 7 times 35, I just did it over here. 245. We're going to subtract 28. Now I don't have any numbers to drop down right now, and I could end with 28, but I can't, when we're dividing by decimals, say remainder 28, because it's not a leftover 28 wholes. We're actually over here in the tenths place, so I have a leftover of 28 tenths. Now if I have 28 tenths left over, I can still divide them into smaller pieces. We can split them into hundredths, because hundredths are smaller than dimes, just like we did with the money when we took the dimes and we made them smaller into pennies in order to split them up. So watch what I can do. Remember when we were doing decimals and we said if we wanted to annex a 0 on the end of the problem, it wouldn't change its value, because 3 tenths is the same thing as 30 hundredths, right? Here it is. 3 tenths, if I split these into hundredths, these 3 tenths right here are the same thing as 30 hundredths. It's the same value. So I can put that 0 on the end and I've changed nothing. But watch what I can do now. I can do another step. We can bring down that 0, and now I have 280. How many 35s go into 280? Look at this. I already checked that out and found out it was 8 exactly. So I can do 8 times 35 is 280. I subtract. Now I don't have a leftover. So if you need to add a 0 at the end of the number because you have a leftover, you are fine to do that. Add that 0 so you can keep on going. You know, sometimes when you go in a calculator, and I'm going to pull my calculator up here. You know how sometimes when you go in the calculator and you do a division problem and it looks like this? Let's see, 23 divided by 11. And you get this decimal and all these numbers? That happens because the calculator is continuing to add zeros to the end of this decimal, and it's going and going and going and going and going and not stopping. Sometimes that will happen, and it won't stop once you add that 0. But for right now, let's just add that 0 to see if we can get there. Okay? All right, let's try one more. Let's do 72 divided by 6 hundredths. Okay? Oh, good, we're 12, so this is one of our basic facts. Let's take that decimal and raise it straight up. How many 12s go into 7? None. And do all our steps. Move over. Drop the 2. How many 12s go into 72? I know 6 times 12 is 72, so 6. 6 times 12 is 72. Subtract, I get 0. Don't worry about that decimal. We raised it up. Move over to the 0. Drop that 0. How many 12s go into 0? 0. 0 times 12 is 0. Subtract. Move on over to the 6. How many 12s go into 6? None. We're going to put another 0. Boy, there are a lot of zeros. 0 times 12 is 0. Subtract and get 6. I have nothing left to drop. I'm left over with 6, so I can't say remainder 6 because those 6s are hundredths. I can make them smaller and turn them into thousands. So we're going to add a 0 to the end, which doesn't change the value of this number. It just gives us another step, smaller pieces to divide. So let's drop that 0. How many 12s go into 60? I know 5 times 12 is 60, so 5 times 12 is 60. 60 minus 60 is 0. Done. Let's double check this one. 6 and 5 thousandths times 12. Do this multiplication problem. Placeholder. Let's count spots behind the decimal. Oops, I'm sorry. 1 plus 6 is 7, not 8. 1, 2, 3 spots behind the decimal. None behind here. So 1, 2, 3 spots behind the decimal. 72 and 60 thousandths. Same. Okay, so now it's your turn. I'm going to put some practice problems down at the bottom of the page. You do the best you can with them. Do them on a separate sheet of paper, and you can either take a picture of them and send to me or write the answers down and send to me. Just do the best you can. If you're struggling and having trouble, moms and dads can help you with this. They've done division like this before. Or you can email me and ask me for help, and I can set up a time to work on it. Good luck!